profound privilege to introduce Dr.Reji. He is a statistician with MSc in demography, MA in economics, and PhD in demography from Kerala University. He has 8 years of research experience and 13 years of industrial experience in official statistics. Presently, he is working as Assistant Director at Labour Bureau under the Union Ministry of Labour and Employment. He was an integral part of several national surveys related to employment and unemployment scenario of our country and other labor-related statistics. He is also an active researcher in the field of applied statistics. He has to his credit more than 10 research papers published in reputed journals. So he will be interacting with you in this session and after lunch session on statistical analysis for engineering research. Today's scheduled lectures for MATLAB for engineering application are shifted to Monday. First 2 lectures will be on MATLAB. So today he will be interacting with you on statistics for engineering research. Sir, please.
Thank you. Thank you. Good morning, all. So today's topic of discussion is statistics. Regarding statistics, this session intended to cover about basic statistics and statistical methods like descriptive statistics, inferential statistics, and statistical data. Mainly in day-to-day life, we are dealing with a lot of statistical techniques. For example, in the day-to-day life, we are using several type of sampling, and we are judging some results from samples. For example, we are cooking in the kitchen. We are cooking rice. We can after boiling the rice, after a particular time, we stir it and take some some portion of rice and check it whether the rice is properly cooked or not. That is a purely we can say that a purely layman statistics. So based on the sample, we will judge that the entire portion of the rice is properly cooked or not. So we are using, knowingly or unknowingly, we are using a lot of statistics in day-to-day life. So first of all, we will discuss about what is statistics. Statistics is the body of techniques used to facilitate the collection, organization, presentation, analysis, and interpretation of data for the purpose of making better decision. So when we record decision, so something uncertainty is there, then only we record to take decision. So uncertainty situations we can handle with the statistics. Statistics is a science of decision making when the situation is full of uncertainties. Next, the necessity of statistics. Researchers and engineers deals with the situation that are poorly defined or must make decision using data that are not precise or well defined. Proper application of statistical analysis may help them to deal with this situation. So in the once again, the engineers and the researchers may use optimization, do optimization of a process or a product or a design required to be met both performance and production specification. So we want to make something. So the particular person required to to optimize 2 things. That is, one is performance and the other is production specification. Which specification? So always we are thinking about the maximize the performance and minimize the resource requirements. So in such situations also we seek the help of statistics. So researchers and engineers need to know how to describe, monitor, and characterize their work, and statistics provides the means. That's the thing. Now we will discuss about the statistical methods, which mainly comes in two parts, that is descriptive statistics and inferential statistics. Descriptive statistics are the basic statistics like mean, median, mode, central tendencies, dispersions, like that. Some basic techniques are involved in the descriptive statistics. And inferential statistics, we are making inference from the sample-based statistics to the population statistics. That we will discuss in detail. So from the picture, we can see that the population, the left side round is indicates the population. Population has a lot of things, and from the population we are taking some samples. That is the right side blue square is there, and from the population we are taking some. Okay. From the population, we took some sample, that is in the right side we can see, and from the sample, from the sample data, we analyze it, order it, arrange it, and analyze it. Then we can generate the statistics like minimum, maximum, mean, mode, variance, standard deviation, such basic statistics. These are descriptive statistics. We can generate such descriptive statistics. Also, we can present the descriptive statistics in graphical format like pie chart, bar chart, histogram, or other graphical methods. From these statistics, we have to generalize. So from the sample, we calculated some mean or median for that sample. So we have to generalize this sample based result to the population. So because the generalization is a process that is called, for that process we use inferential statistics. So we have to inference the results, sample results to the population results. So that process is called inferential statistics. That there is a lot of tools for inferential statistics that we will discuss in the afternoon session. So next topic is descriptive statistics. Descriptive statistics are the techniques to summarize data in tabular, graphical, and numerical methods. So what we will do, we will collect the data from the field or sample based data. So we will have to summarize it, clean it, arrange it, and summarize it. So these techniques are commonly known as descriptive statistics. In descriptive statistics, process involves collecting data, organizing and summarizing data, and presenting it. Collecting data means we want to experiment the performance of an engine or car engine. So what we will do? So we will collect first. We will decide what are the parameters we want to collect or we want to measure. So first we will decide the parameters we want to measure. After that, we will select some sample engines and collect the data from that sample engine. After that, we will organize that data in a particular manner, and after that we will process it and summarize it. Then we will present the data. This is the entire process of descriptive statistics. The purpose of descriptive statistics is to describe the situation. So we have to describe. So what we will do, we will collect the data from different sample engines, and we have to summarize it and present it. And present it means we have to tell to the company management or some to R&D groups that this is the situation of this engine regarding these parameters. So our purpose is to describe the situation. For example, a management of a car company would like to have a better understanding the cost of parts used for an engine service. So that is the interesting thing for the car manufacturer, because they want to know how much costs are paid by the customers of their car owners for an engine service. So we have to collect the data. For first, we will collect the data. We will select some service stations. We will select from service stations from different places or particular place, and we will identify some engine services of the particular car, and we will take the data regarding the cost of parts the owners paid by. So in such a way, we collected the data. So below I shown is the data we collected. The cost of parts of 30 engine services were collected and presented here. The first car service engine service was costed by 9100, second 7800, and so on is there. So this is the data. So in order, this data gives a vague idea to the management. So what we will do, we have to summarize and present to the company management. Then only they will get a quick analysis or quick idea about this analysis. This example we can first we will summarize it using a tabular format. Then we will go how to make it in a summarize in a graphical format. First, the tabular format. So the data, the previous data, we can see that the data are here. 30 number of data are there. First, we will check which is the minimum number and which is the maximum number. Okay. So maximum number is 10,900 and minimum number is 5,200. So we can make it into classes. So class intervals we can make. So I started with 5,000 and made a 10 class interval. So 5,000 to 5,900, 6,000 to 6,900, 7,000 to 7,900, so on, 10,000 to 10,900. So I made 6 classes from that data. After that, I counted from the previous data that how many car services cost between 5,000 and 5,900. So we can find that only 2 car services was there. So accordingly, we filled all the data 2, 4, 13, 2, and 2, 6, and 3. Total of the frequencies will be 30. So this 2, 4 we can term it as frequency of that particular class. So we can see from this data, frequency data also, the highest frequency fall in that group 7,000 to 7,900. So we can easily say that maximum people paid between 7,000 to 7,900 rupees. So accordingly, we can we can take the percentages of frequency. So first frequency is 2. 2 divided by 30, we will get to the percentage of frequency, that is 6.7. Like that, we can calculate the frequency of each frequency, percentage of each frequency, that is 6.7, 13.3, 43.7, like that. It should be added up to 100. So again, we can go through the percentage frequency. The highest number is 43. So we can, from that figure also, we can conclude that the maximum cost borne bear by the car owners is 7,000 to 7,000, between 7,000 to 7,900. So again, we can present this the same figure in a tabular form also. So in the below that in the graphical form, the below graphical form is there. So here I draw a histogram. So in the x-axis we can see the class interval, and y-axis we can it's there in frequencies. So from the graph, from the first look, we can see that 13 is the highest peak. So 13 represents 7,000 to 7,900. So we can conclude that 7,000 to 7,900 is the maximum people paid for the service cost. So before going to the other descriptive analysis, we are one have to require to understand the type of statistical data. Okay, there is different types of statistical data. So first classification is quantitative and qualitative data. Quantitative data involves attributes such as sex, occupation, location, or some other categories. So simply saying this type of data is a categorical variable, categorical type. Categorical means we are simply assigning some values to for representing some characteristics. Suppose gender or sex, we can represent male and female. We can assign one for male and two for female. Like that, we can classify good, very good, or like that. So we can assign one for good, two for very good. Like that, we can. Such type of variables are called categorical variables or quantitative variables. As qualitative variables, sorry, qualitative variables. Next is quantitative data. Quantitative represents the quantity or amount of something such as length in centimeter, weight in kilograms, like that. Whatever may be quantity, we are representing in the in some numbers by quantity. So such data are called quantitative data. So next type of classification is discrete data and continuous data. Discrete data assumes values that can be counted, like 10, 15, 12, 13, like that. Such values we called discrete data. Discrete data and continuous data can assume that all the values between any two specific number, means 12.5, 13.8, like that. Such values we termed as continuous data. For example, length, we can measure length, width, weight, and volume in continuous scale only, and discrete some age, completed age, like that. Such data we can quantify in discrete data. So statistical data, again, some more classifications are there. So on the basis of their measurements, we can classify statistical data in two categories. That is cross-sectional data and same time series data. Suppose we are measuring something in at a time, same time. So such type of data is called cross-sectional data. For example, we are measuring the mileage of a particular car. Suppose we are measuring the taking the data from 10 or 100 different cars at the same time, same period. So we can term such data as cross-sectional data. And time series data is the we are collecting observations are measured at successive points, because for example, temperature, we are measuring temperature. So first 6 o'clock we measured the temperature, then 7 o'clock we are again measuring the temperature, like that. Hourly basis we can measure, daily basis we can measure, or monthly basis we can measure. So that is a observations are made at successive points, that is points in time. That is called time series data. So time series data and cross-sectional data are important because different statistical methods are built for different type of data. So some analysis is meant for cross-sectional data only, and some analysis is really meant for time series data only. So this type of classification is also keep in mind while going through the statistical analysis. So again, the quantitative data. So we already discussed about qualitative and quantitative data. Again, we are dividing the quantitative data into four categories. That is nominal data, ordinal data, interval data, and ratio data. Okay, nominal data represent the arbitrary codes. That means, so for example, there is no physical difference between two things, then we can assign nominal values to them. So for example, colors, red, green, yellow, we have to assign some numerical values to them, but we can't categorize or weight them. So on that case, we will simply assign 1, 2, 3, 4, 1, 2, 3, 4 to red, yellow, and violet. But we can't say that the three we assigned 3 to violet, so it's more weight. It has more weight. No such meaning for that. So nominal data has equal weight for all the numbers. So for example, course numbers, we are assigning course numbers to different courses, and subject numbers for different subjects. There is no discrimination in the numerical values. So next is ordinal data, convey the rank in terms of importance, strength, and sensitivity. So we can say that nominal data have no ranking. That is important. But ordinal data we have ranking. For example, so we are grading the students 80%, 70%, and 90% like that. So there is weight. There is a weight. 80% is excellent, and 70% is good, and 60% is fair. So we have a weight. Weights are 80, 70, and 60. So accordingly, we have to differentiate the three items. So such type of data is called ordinal data. And interval and ratio data commonly used in analysis in a common sense, but for understanding I am separated here. And interval data allows only addition and subtraction. The distance between numbers is known as constant size, but the zero value is arbitrary. So for example, the distance between number, so 10 to 15, what is the difference? Only 5 is the difference. 85 to 90, that is also 5. Such kind of data, that difference only, that's we already said that addition and subtraction is allowed in this type of data. So such type of data is called interval data. Ratio data allows all kind of arithmetical operations. There is no discrimination. All kind of arithmetic we can do on ratio data. So size, weight, strength, all these are the examples of the ratio data. We can use any type of arithmetical operations on this. Data processing on a natural 0 point is organized into the measure which different of meaningful. Okay, for example, money, income, sale, profit, loss, height, all these type of data are ratio data. So this here we can see the pictorial representation of data types here. We already discussed in the last few slides. So the left side, the scale of measurement is there: nominal, ordinal, interval, and ratio data. The columns are represent categorical, discrete, and continuous. Above that, quantitative is there. All the qualitative data are categorical. Okay. So nominal data, all the categorical data are nominal and ordinal only. Okay. Nominal data, for example, male, female. We can assign 1 for male and 2 for female, but there is no difference in 1 and 2. 1 and 2 holds equal value. Ordinal data, that for example, good, better, best. So we can grade it 1 for good, 2 for better, and 3 for best, like that. So the next is quantitative data. Quantitative data have two categories: discrete and continuous category. So again, under quantitative data, ordinal scale is will come. So ordinal scale we can measure descriptive and continuous data also. The same way, interval scale also we can measure in descriptive and continuous, but ratio we can measure in continuous only. For example, discrete scale is 10, 15, 20, 25, like that. We can measure that. Continuous we can 5.2, 6.2, or 8.6, like that. Any way, any fraction we can measure that. Next is measures of central tendency. We already discussed about the tabular and graphical representation of descriptive statistics, and now we'll go to the other measures of descriptive statistics, that is measures of central tendency is a part. So measures of central tendency, the purpose is to describe where distribution's middle or center value. So many times we use the center value as a representative picture for a data or a situation. So for example, average age of students in a class, so that will give a meaningful value to the others. So sometimes the students of that class age from 20 to 25. So we can easily say is that. Otherwise, we have to say 20 years students 4 numbers, 21 years 3 numbers, like that. If you have to describe that, so we can easily convey that Average age is around 23 years. Okay, so that is the easiest way, and it will convey the meaning easily to others. That is the thing. Okay, the actually measures of central tendency contains totally 5 measures. So commonly used are three: mode, median, and mean are the three measures commonly used. There is geometric mean also there, have harmonic mean also there, but commonly used the three means. We will discuss the three averages here. uh, so central three central tendencies here. So first is mode. Mode is the how we can get mode from a data. Mode is the most frequent value of the distribution. If you place all the data, if you gather after gathering all the data, we have to count each data how many times it's repeating. So we can say that the highest number of repeating data is the mode of that series. So for example, below the example is there: 10, 15, 12, 15, 12, 10, 12, 20, 18. So from this we can see that 10 repeated for 2 times, 15 12 repeated for 3 times, 15 2 times, and 20 one time, and 18 one time. So from this 12 repeated maximum times, that is 3 times. So mode of this series or this distribution is 12. So the one of the important thing is the mode is the only measure that can be used within nominal level of measurements. So there is no value difference between the numbers. So we can use only mode. So in the case of this males and females, so how we can say that mode we can use that. Otherwise, how we can male for 1 and female for 2? If you take a simple average, that will give 1.5. Is it meaningful? That's not meaningful. So that is why the level of measurement is important. So mode is the only measure can be used with a nominal level of variables. Next is median. Median, the most value of the distribution. Sorry, middle value of the middlemost value of the distribution. Then in order to get the median, what we will do? First we will gather the data, gather the distribution or data, and what we will do? We will arrange it in ascending order or descending order. The best practice is to ascending order, is descending order. Then count the total number of observations, number of values in that distribution. So here the example is here. We have 2, 2, 6, 9, 11. Total number is 5. 5 observations are there. So what we will do? We have to add 1 with 5. 5 is an odd value. That's why we have to add 5 plus 1 is equal to 6, divided by 2 is equal to 3. So after arranging its ascending or descending, we can take third item from left side or right side, any side we can take. So third item, that is 6. 6 is the median of this series. Then the number is even. The n number, the total number of items is even. Then what we will do? We also here also we will arrange the data in ascending order or descending order. After that, we will divide it by total number divided by 2. That will give, that is 6 divided by 2 is equal to 3. From the left side, third item, and right side, third item. That will be 5 and 9 is the two numbers we'll got. Take the average of that. That means 5 plus 9 divided by 2. We will get 7 as median of this. Okay. So in the case of mode and median, is a benefit is this will not affect the extreme values, because we are not considering the extreme values, higher value or lower value of this series. We are concerning about the middle value of the series. So in order to overcome this demerits, we will the statistician find that mean. Okay, mean is defined as the sum of all the individual observations of a distribution is divided by the number of observations. Okay, actually how we can derive mean? Take the sum of all the observations and divide it by total number of observations. is symbolically notated as x bar. X is x represents the number values distribution, and bar, put a dash on the top of x, is called x bar. So the formula to calculate x bar is equal to sigma xi divided by n. Sigma xi represents that sigma means summing of all the x values. Here the example 3, 2, 5, 9, 11 and 12 are the different values of x. X1 is 3, x2 is 2, x3 is 5, like that the values are there. So we have to add up all the values. So in the below is shown that xi is equal to 3 plus 2 plus 5 plus 9 plus 11 plus 12. That is that we will get 42, and total number of observations are 6. That is x bar is equal to 42 divided by 6, that is 7. So we got the mean as 7. Here the main one of the merit or demerit is it will affect extreme values. Suppose this is the in this case the mean is 7. Suppose we add one more number as 52. So we will add 52 with 42. What will happen? Is 94. 94 divided by 7. It will give a higher value. So that's not a representative average. So always try to use mean in such a cases that no extreme values should not be there. Next is measures of dispersion. Measures of dispersion is mainly consists of variance, standard deviation, range, etc. So how we are, what for what purpose we are using this dispersion? To know how distributed the data. So already we discussed that the main demerit of mean is affected by extreme values. So if we calculate the dispersed measures, we can find that how dispersed the data is. Accordingly, we can decide whether mean can apply or mode can apply or median can apply. So the various measures under measures of dispersion are variance, standard deviation, range, etc. This first we will discuss about range. The scale of distance from the highest and lowest. So here the symbol range is a simple thing. So in order to calculate the range, what we will do, we take the highest number and lowest number of the series and minus it from highest value. From the highest value, we have to minus the lowest value. From the example shows that 3, 2, 5, 9, 11, 12 is the series, and 12 is the highest and 2 is the lowest. 12 minus 2 is gives the range of this data. Here also is considered extreme values only, not the middle values or inner values. Next type of dispersion is standard deviation. Standard deviation measures the standard or typical distance from the mean. Actually, standard deviation is based on mean only. So in order to calculate standard deviation, we have to derive variance also. So first we will check how to calculate variance. Variance is also the individual distance from the mean of each individual observations. So the sum of squared deviations from the mean, that is sigma xi minus x bar the whole square. That means first we will calculate the mean from that distribution. After that, we have to minus that mean from each observation that will and square it. If we take the difference and sum it up, then we will get 0, because we are minusing mean from each observation. So mean is the middle point. So naturally, some observations are we will get some observation in plus positive side and some observation in the negative side. So we will add up the symbol xi minus x bar, will get 0 value. So in order to overcome that, we will go for a squared value. So sigma xi minus x bar the whole square divided by n gives the variance. So sum of square, first we will calculate the sum of square and simply divide it by the total number of samples in that distribution. After that, we got variance. Take the square root of variance. We will give that will give standard deviation. That is square root of sigma xi minus x bar the whole square divided by n gives the standard deviation. Standard deviation is the typical distance from the mean. It says that how disperse the data. So see that the 163 is the mean, and the standard deviation we can say that 3 is the standard deviation. So add 3 from 3 to 163 and minus subtract 3 from 163. So we will get 160 and 166. That we can simply say that mean plus or minus 1 standard deviation. So we can see that if you go for the data, we can see that around 68% of the total observation will come under this range, and the same thing mean plus or minus 2 standard deviation, around 95% of the total observation will come under this range, and the so on 97% of the 99.97% of the observations come under mean plus 3 standard deviation range. So calculating the variance, here the example how to calculate the variance and standard deviation. Number of credits taken by a sample of 8 students in a class. So we can see that 8 students, number of credits, each students how many credits they taken. So 10, first student 10, second 9, 13, 17, like that. We recorded all the data and sum it up, that is 112, 112. So we have to calculate the mean first. So 112 divided by 8, that will give 14. So next step, what we will do? We have to subtract this mean from each individual value. So 10 minus 14, that will give 4. 9 minus 14, that will give minus 5. Like that, we have to calculate xi minus x bar in the next column. So the total will add up to 0. Otherwise, some mistake is there. Total should add up to 0. Okay, then we have to square it up. So minus 4 square 16, for minus 5 square 25. Like that, we square it up. Again, add it up. The total is 72. So 72 divided by 8. 8 is the number of observation. We'll get 9. 9 is the variance, and we have to calculate standard deviation from the variance. So we'll simply take the square root. Square root of 9 is 3. So 3 is the standard deviation. So we got 14 as mean and 3 as standard deviation. So where we can use, actually mean and standard deviation combinedly we can use to judge something, some data or some characteristics or something like that. So here I present an example here that the width of the road. Suppose we want to measure the quality of road by measuring the width of the road. So we, for example, we took 3 highways. We took 3 highways: highway 1, highway 2, highway 3, and measured the width at different points for 10 kilometers. Each 10 after every 10 kilometers we measured width of the road in the 3 highways. Suppose we 100 places we took width of that road in each of the highways. Okay. After that, we calculated mean and standard deviation. Mean and standard deviation we calculated. So what happened? In all 3 highways, we got mean of around 100 only, 10 only. 10 meter width is there for all the. Okay. So we can, by looking on mean, we can say that all the highways are equal. All the highways have equal widths, but we have to calculate standard deviation also. So standard deviation says that how scattered the data, the 100 sample taken from each highway, how scattered the 100 sample. So from there, that we can say that which highways more provides more consistent widths. So the standard deviation we calculated that first highway 0.2, second highway 0.5, third highway 0.7. These are the three standard deviation got, but the mean is same for all the highways. Mean width is same for all the highways. Here we can say that 0.2 because that indicates that a less scatter means that indicate that the 100 measurement taken from highway 1 consistently gives around 10, around the mean 10. What we can say that the most around 67 percentage, 66% of the data is coming between measured data is coming between 9.8 and 10.2, and 99% of data is coming between the width is coming between 9.4 to 10.6. So if we calculate in such a way, the second case, so 97% of the width is coming between 8.5 and 11.5. So the variability is high in second and third. So we can conclude that highway 1 is better when compared with the 2 and 3. Okay. So the high standard deviation shows that a data is widely spread. The widely spread data's mean is less reliable. And the low standard deviation shows that the data are clustered closely around the mean and more reliable. So the same case we can say that the company, so for example, Maruti Swift, we have to measure the average mileage. So we are taking we have to take the samples from different cars, 100 cars or something. So accordingly we measure some other cars, other company cars like Honda or same category cars. We measured that Honda or like Hyundai, like that 3 cars we are take. The average mileage we can take, and accordingly we can calculate standard deviation also. Using these techniques, we can say that which cars gives a consistent mileage in that. So mileage may vary. Mileage Swift gives 22, or and Hyundai gives 21, or this one another car may gives 23. So lekin Swift's average this standard deviation is very small. Then we can say that even though the mean is smaller than this one, so Swift is giving 21 kilometer and the standard deviation is around 1 only. So the range is between 21. First standard deviation level is 20 to 23. Sorry, 22, 22. But in the case of 23, Hyundai gives 23 kilometers. But what happened? The standard deviation is 4 or 5. That will the first standard deviation will go to 20 to 28. That their variability is wide and consistency is less. So we can say that some cars may give 67% of the cars may give this much percentage, this much range of mileage, like that. So such analysis we can employ such techniques. So we can use similar techniques in other engineering application, efficiency of machines and efficiency of other computer systems, like that. We can apply these things there. Next is an example, cost of parts. The same example we started with the cost of parts used for engine service. So 13 number of cases we observed and collected the data, and the descriptive statistics I measured on the basis of that data is minimum, maximum, mean, mode, median, variance, and standard deviation. Whatever maybe we discussed in this session, all I calculated here. So, and standard deviation is also there. So on the basis of that about descriptive statistics, we can infer that mean is around. We actually on the basis of graphics and the frequency table, we judge that the maximum the car owners spend between 7,000 and 7,900 rupees, but mean says that exactly around 8,000 rupees. On an average, they are spending around. They were spent around 8,000 rupees, and mode is around 7,500. That's mode is mainly depends on the this one most frequent item. That's why that's came under the range that 7,000 to 1,500. Median is also calculating the same way, 7,550, and variance and standard deviation. Standard deviation is 1,434. So we can conclude that we can say to the company management that around 60,000, 68% of the car owners spent between 6,565 to 9,434 rupees for replacing the parts of engine services. And further, we can say that 95% of the car owners were spent 5,131 rupees to 10,868 rupees for replacing the parts of engine. Like that, we can say 99% of the people how much they are spending. From this statistics, company will get an idea about how much the cost is bear by the car owners of their company. So accordingly, they can modify their engines, them, or otherwise their service patterns like that. They can do accordingly. So next is inferential statistics. So we will discuss the introduction of inferential statistics in this session. After that, how to apply inferential statistics using some tools like t-test, ANOVA, correlation regression. That we will cover in the afternoon session. So statistical inference is a process of using data obtained from a small group of elements, that is called sample, to make estimates and test hypotheses about the characteristics of a large group of elements, that is called population. So we already discussed about the sample and population little bit. So actually sampling is a different area. Sample and sampling are a different area. That's a vast area. So in short, I will say something about sampling. So we want to study a big group. For example, we want to study the manufacturing defect of a particular product. So we can't analyze, we can't test all the products manufactured by the company. So it's impractical. So it's very difficult to do. So it requires a lot of manpower and money power. Also, it requires a lot of such kind of things. So we have to take some sort of samples. So the population is the entire production, and sample is the selected article we checked. So we are always taking samples to reduce our workload, reduce the expenditure, reduce manpower. So for these things, so we have to measure the parameters from sample selected, and we have to generalize it for the entire population. So we are collecting the percentage of defects from the samples, and we have to generalize is that this much of the samples collected were defective. That indicates that this much percentage of the entire production is defective. So accordingly, management can take necessary action to improve the production technology. So some of the examples are given below. First example is fuel efficiency of a make and model is determined by sampling of few cars. So the car makers, they won't test all the cars manufactured. It is not possible. So what they will do, they will manufacture some cars. They are manufacturing the cars, and we are taking some samples of cars from the different stages of manufacturing, different stages, and test the cars accordingly, and they will collect the data and analyze it and generalize it for the population entire production. So the second is time required by the robot to do a respective task must repeated task must be determined by a few sample observations. So we manufactured a robot to undertake a particular task. So now mechanization is going on. So we prepared a robot to do a particular task. So what we will do, we can't say the time to undertaken to for a particular task is task may vary from the efficiency of that robot time to time. So we have to check the consistency of time taken by that robot for doing that particular task. So we have to assess the time in several processes. Otherwise, we have to assess each and every process, how much time it's taken, how much time it's taken. Instead of that, we will take a few sample times for some particular task, and we on the basis of that time we can judge that on an average this much time is taken by that robot to that particular task. And third is strength of steel is determined by laboratory experiment, because so strength of steel, we can't send all the steel manufactured by the company to the laboratory for testing the strength. So what we'll do, we will take a sample portion of that steel and send it to laboratory for testing, and we are generalizing it for the entire produced steel. So such situations, we have to generalize the sample based results to the population, entire population. So such situations we are using statistical inference. Statistical inference involves estimation, hypothesis testing, and the purpose is to draw conclusion or inference about population characteristics from the sample. Population and sample. We are already discussed about that. Population is the entire group, and sample is the some groups collected, some elements collected from the entire groups. So the samples collected from the entire group, on the basis of that sample, we collect data and calculate the sample-based parameters. That is called statistics, and we have to generalize it for the population. So sample mean we calculated on the basis of sample, and standard deviation on the basis of standard sample, and we have to generalize this sample mean and standard deviation for population, for the entire population. That is called a parameter. So this process of generalization based on sample mean and so based on sample statistics is called inference. Statistical inference. So here the diagram shows that how inference process works. The process of statistical inference indicate that first the example is the same of cost of production, cost of parts used in the engine services. First one, population consists of all the engine services. Average cost of parts is unknown. So in that case, the entire population is taken. That is all the engine services. All the engine services, the cost of parts is unknown for us or for the company. And we for knowing that the cost of parts for engine service, we took 30 samples from that the entire population. From that sample, we assessed the cost of each engine service cases, examined and collected the data accordingly. The sample data provided a sample average cost of 80. So in the last slide we saw that the average cost of engine service was 8,000 only per engine services. So we derived the mean statistic as 8,000. The value of sample average is used to make an estimation of population average. So we calculated the sample average, and we have to measure generalize it for population average. So here we take the help of the inferential statistical inference for generalizing it to population. So this is the end of the first session. So next here now we will do some practical things with the help of Excel. Microsoft Excel is the common tool. So each and every on all computers we will get the with Excel software. So I choose the Excel software for this purpose. There is a lot of statistical softwares are there, SPS, SAS, Stata, SPSS, and R. A lot of statistical specific purpose tools are there, but Excel is a common thing. It have ample statistical capabilities also. So I used this software for demonstrating how to do the descriptive statistics. So first we will open the Excel, then enter the data. Here the data is already entered. The data is same as the service cost of the engines service cost of in engine service. Then here first data is first data is 9,100. Second data is 7,800. So we have to calculate the summary statistics here. So first summary statistics. How count is summary statistics, one of the summary statistics, that is n. And here we have to count the data. So here is 30. So how to count in Excel? How to count the number of observations in Excel? It is simple. So press on any cell and press equal sign. After that, we have to type count, CUNT, count. It will show here, count is here. Then select the range or number of values. So we have to select like this and close it. Close the bracket, press enter. It will give the total number of observations in that number. Accordingly, set next type of this is minimum, maximum we have to calculate, and mean, median we will calculate here. So first of all, inserting a formula, basic condition is first press equal sign and that. So we have to find the minimum of that data series. That is so simple. After is equal to sign, so minimum min, minimum 6 is there. So minimum, after that bracket is there. Select the range. Okay, minimum we got at 5,200. Like the same way we can calculate maximum. Max is the function maximum. So maximum we will get. Next we have to calculate our mean. Mean, the function is average. Average, we have to select the entire data and press enter. We will give this 8,000 as average. And mode we have to calculate. Mode, again select the entire range. Mode, we got the mode. Then median is there. It's equal to median. Okay, this is a median. Now we have to calculate variance. So is equal to variance. Variance sample is there. You can use so population or sample both. There is no difference. So select the range, we will get variance of this series. Again, standard deviation we have to calculate. You can calculate, simply take is equal to yes, square root of variance is the standard deviation. You can directly do this, otherwise there is a function also, standard deviation dot s is the function. Select the entire range, we will get the standard deviation. So these are the descriptive statistics we already discussed here. In this way we can generate the descriptive statistics. But in the specific purpose, but in the software like SPSS or some other R, you will get if you click on descriptive statistics, that will give the entire descriptive statistics. So in addition to many other descriptive statistics also there, so they will give the entire descriptive statistics for that data. So Excel we have to do in such a way. So in addition to this, we can also use graphical representation also. So we have to we can draw a bar diagram if you want. This is the bar diagram. We can and one main thing is we have to do the histogram, that we prepared that for that we have to define the range first, 5,000, 6,000, 7,000. For that we will go to data analysis and histogram is there. So input range is, you have to give the input range, and the bin range is this one, the range, the class we prepared, and output range we can define it as here, anywhere the blank space you can click. So this will give the frequency. Okay, in this way we can make the frequency. On the basis of this, otherwise we can directly make graph using this also. In the data analysis, histogram, this data is there, chart also. So it will give the histogram chart also, simply. Okay, in this way we can use the calculate the descriptive statistics in using Excel. Actually, this data analysis, normally in computers, data analysis package is not enabled. That is the add-on package that is not ever enabled. For enabling that, you can go to, you have to go to the options of Excel and go to add-in and Excel add-ins. Select Excel add-ins and go. Select the analysis 2-pack and OK. It will automatically enables the analysis 2-pack tool pack. So I already enabled, so I am not doing that. So this is a one-time process. Using this process, you can enable the data analysis package in Excel also. So this is the end of this session. So any questions